Here we've got a motor, and you can see that there's 6 ends of wire, and each of those ends belongs to a winding. Okay, so as we've seen, we've got V1, W1, U1, U2, V2, W2. So, but we've no idea which of these two form one complete winding. So of course we need to find out. We also need to check the resistance of the windings is pretty much the same to ensure that the motor is working properly and well balanced. And for that we need to use a low resistance ohm meter. The important thing is, before we start, to make sure that the meter is accurate and that it's actually working correctly. And of course, very importantly, we've zeroed the leads. Now, zeroing the leads is something that needs to be taken pretty seriously, because if we look at these crocodile clips, we've got one piece, which is this piece here, which moves, and we've got one piece here, which is connected directly to the lead. Now, if I'm zeroing the leads, what I'm actually doing is measuring the resistance of these leads and the connection of the crocodile clips. If I connect it to the two moving parts, obviously the joints here are going to offer a higher resistance. So when I zero the leads, I'm probably going to zero them too much. So when I take a reading of a resistance of a winding, the resistance is going to come out less than it actually is, because I've taken off too much resistance for the leads. So when I zero the leads, I need to make sure that I get the solid bits of the crocodile clips touching each other. Push the ends together as tightly as you can, just to make sure you've got a good connection, and if there's any dirt or anything inside the crocodile clips, you push through that. These are fairly new, so I'm not going to have too much of a problem. With this instrument, we can see that these leads have got a resistance value of 0.37 of an ohm. If I just push the button to zero it, there's a little symbol comes up in the bottom left-hand corner. That tells me that the instrument is now zeroed, and any measurement I take will be less the value of the leads. Okay, so the next step for me really is to identify each end of the windings. It really doesn't matter how I identify them. I can call them whatever I like, but I do need to find each end. So first of all, we'll say we're going to look for the end of winding W. All I need to do is connect one end of the crocodile clip tightly to one end of a winding, and then between, bit of luck, I got it first time. So between two ends. So this, the red and the green, are the ends of W winding. So we've got W1, W2. So, and the resistance value is 1.85 ohms. So if I just mark these, or even just for now twist them together so that I know which ones are which, I can then move on and do the next winding. So hopefully I'll be just as lucky again. Not this time. So that's clearly those two aren't connected. That one is, and lo and behold, I've got exactly the same reading again, 1.85, which is telling me that that's a really good value. Okay, that's a good reading. They're both the same. So I need to identify those two and make sure I don't get them lost. So the easy way really is just to try and pull that out like so, twist it together, and now I know that those ends go together. That could be W, that could be U, and now I just need to identify that V is going to be the same resistance. So same process, make sure it's nice and tight, touch it together, 1.85. So this really is a good motor. The resistance of the windings are exactly the same, and I can now proceed to connect it up and know full well that it's going to work perfectly. Now I've connected the motor, just 6 individual terminals to start with, and really what I want to do, just to be absolutely sure that I've not made a mistake, is just check that I've got the correct ends. So on this terminal block, this says W2, this says W1, so we know they should be together. So if I join them together, I should get a reading, and they're together. Now I'll go on to V1 and V2. Again, take a reading, close enough so I know I've got the right winding. Now to U1 and U2. Again, close enough. So I know I've got the right winding. Now what I need to do is connect the motor into star. If I wanted to connect this motor in delta, I would need to run 6 wires up to a motor starter, and inside the motor starter there's contactors that change from delta to star, which we'll look at in another video. If I want to connect a motor into star, all I need to do is find 3 ends of the windings and join them together. In the motor terminal block, that's fairly easy because all I need to do is link either V1, W1, U1 together, or could you even use V2, W2 and U2 together? Whichever way I do it, it really doesn't matter. So this motor now is connected in star, and for that to run, properly, all I would need is to connect 3 phases, L1, L2, L3, to those 3 terminals, and it would run perfectly well. The next thing I need to do, of course, to make sure the motor is serviceable, is do an insulation resistance test. But because it's a motor, and it's quite a big motor, we want to check the quality of the insulation over a period of time, really. So just a quick insulation resistance test really isn't suitable for a motor that's in continued use. We need to do what's called a polarisation test on the motor, and for that we need to do a test for 1 minute and record the readings, and a test for 10 minutes and record the readings, and then do a small calculation by dividing the readings we got after 1 minute into the readings we got after 10 minutes. So we'll do the test first, and then we'll talk about what the readings represent a little bit later. Okay, so before I start the polarisation test, what I really need to do is just earth all of the windings simply to earth, just to make sure they're completely discharged. Okay, that's very, very important. Once I've done that, I connect the tester like so, connect it to a good earth, push the button, lock it so that it tests for 1 minute. So we can see now that that's the reading after 1 minute. We now need to wait a further 10 minutes to see what the reading would be after that. And I'll explain what happens in a moment or two, but first of all, we'll wait our 10 minutes and see what reading we get. The first reading we got was 2.1, and then after 10 minutes, we ended up with a reading of 7.2. What we need to do now is divide the reading that we got after 10 minutes by the reading that we got after 1 minute, and the value needs to come out. Greater than 2 means the motor's serviceable. If it's greater than 3 or even 4 or 5, it means the motor is in excellent condition. The windings, the varnish around the windings, or whatever insulation there is in really good condition. So we'll just do a quick calculation on the board just to find out what the values actually are, and that's our polarisation done. When we carry out a polarisation test, really what we're testing is the insulation. And the reason we need to do it over a period of time is because it takes a while for the insulation molecules to polarise. If we look at this, this would be, say, a winding in a motor when it's at rest with no current flowing through it. We can see that if we pass current into this, it can find paths through here fairly easily. So after 1 minute, the molecules of the insulation would be just randomly placed. So the insulation, it's got lots of paths for the current to flow through. It takes a little bit of time for the molecules to polarise. So that's why we need to do the test for 10 minutes, because after 10 minutes, the molecules will polarise and they're facing in the same direction, and they offer more resistance for the current to pass through. So that's why we need to do the test. When we did the test, the readings we got after 1 minute was 2.1, and after 10 minutes was 7.2. So I need to divide the 1 minute test into the 10 minute test and see what the value is. The value comes out at 3.42. Anything above 2, the motor would be okay. Above 3, between 3 and 4, the motor would be in good condition, and anything above 4, the motor would be in excellent condition. And as you can see, this is a good motor, and all of the tests we've done show that to be correct as well.